Okay, ladies and gentlemen, we are now going to talk about absolute value inequalities. Remember, an inequality is anything with that less than greater than sign. And in this case, they are very similar to all the stuff we were doing before with absolute value equations. For example, if we have the absolute value of x is greater than 3, well, that means that we have several possibilities. So that just means x has to be greater than 3. And it also means that x has to be less than -3. Okay? Because remember, one of the things we talk about here is that with inequalities, whenever we were dealing with the negative, we flip the sign. So when we flip it, let me bring this up, we flip the sign and we add that negative. So it's not just one thing, it's both. I know it sounds a lot more confusing than other things, but this is just how this works. Okay? So let's say we have the absolute value of x plus 2 is less than or equal to 5. Okay? So again, we're still going to need that positive and negative. So let me just write the positive here. And we're going to do the same thing. So x plus 2 is less than or equal to 5. Subtract 2 from both sides. X is less than or equal to 3. But remember, we also have to do that negative one. Once we get that absolute value symbol by itself, this is how this works. So we have x plus 2, but remember we got to flip that sign. So instead of being less than or equal to, is going to be greater than or equal to. Instead of a positive 5, we're going to make it a negative 5. And then subtract 2 from both sides. Sorry, drawing straight lines are not my thing. So when we look at this as a graph, we know that x has to be less than or equal to 3. Okay, so we're going to try and draw a line. You guys know how I am with those. So we're going to make this -7. This will be 0. This will be 3. So x has to be less than or equal to 3. So we have that closed dot. I'd put it on there, but you guys couldn't see it then. And has to be greater than or equal to -7. So that's going to be right there. And then remember, since this is one of those compound, this is that and thing. What I'm going to do, let me see if we can get a marker that's a little bit bigger. It has to be anywhere in between here. Okay? Because it is kind of that compound inequality with being an and, because it is x is less than or equal to 3 and x is greater than or equal to -7. Okay, let's go through a couple more examples. So it's the same thing just like we were doing before. So this time we're going to do absolute value of x plus 2 minus 3 is less than 8. Nope. Let's make that something else. I don't want that to be 8. Let's make that, let's see. I want to make this a 4? No. Let's make this a 3. So again, we're going to need to get absolute value by itself first. So we're going to add 3 to both sides. These cancel. Absolute value of x plus 2 is less than 6. Okay. Now remember, we're back at that point where we need a positive and a negative. So I have x plus 2 is less than a positive 6. Subtract 2 from both sides. X is less than 4. But remember, we need that and. So we're going to do that negative one. And so we have x plus 2. Flip our sign. Instead of saying less than, we're going to say greater than a -6. So don't forget about that part. Subtract 2 from both sides. These cancel. X is greater than -8. And again, it's that compound inequality. It's that whole thing. So when we're graphing it on our wonderful number line, I'm going to have a -8 here. I'll put a 0 here and a 4. And then so it has to be less than 4, which is an open circle. And it has to be greater than -8. So again, it's that open circle. And then we're just going to grab everything in the middle. Okay? And so just keep following these rules. It's the same thing. So if we were multiplying and dividing, do you guys want to see a multiplying and dividing? Okay, let's do that. So let's say we have 2 times the quantity x minus 3, the absolute value of x minus 3 is less than or equal to 10. Okay, so the first thing you have to do, because we have to get that absolute value part alone before we can do anything else. I'm going to divide by 2 on both sides, because then these cancel, and then we're left with the absolute value of x minus 3 less than or equal to 5. Now that we have that alone, we're going to go back to that whole positive, negative, x minus 3 less than or equal to 5, adding 3 to both sides. X is less than or equal to 8. And then we have our negative. And then we say x minus 3. Instead of less than or equal to, it becomes greater than or equal to a -5. So add 3 to both sides. And then x is greater than or equal to -2. Now let's look at our graph again. I'm going to have a -2 here. I'll put my 0 here. My 8 is way over here. Okay, this is a less than or equal to, so I'm going to do a closed circle. Because remember, when it's that or equal to, it includes it. And greater than or equal to -2. So again, that close sign. And let's just do our marker. And we're going to fill it in just like that. Okay. Now, if you get something where they cancel out, remember, it only works if the statement's true. So just be careful, because sometimes after you cancel, you might get answers where you end up with -3 is greater than or equal to 0. Is this true? Is -3 actually greater than or equal to 0? It's not. So in this case, this would be one of those special case no solutions. Other times, you might end up with something like this. 5 is less than 10. Well, ask yourself, how often is 5 less than 10? Okay, remember how we talked about how that kind of thing is like an infinite forever thing? So you could say it's an infinite, or we could also say all real numbers. You'll see both of those. Because this will always be true. That's the whole point. Is this always going to be true, or this never going to be true? Okay? And remember, if you have questions, please ask. I'll see you guys later. Next video is going to be on graphing.